Now, I'm going to teach you how to solve this question without really using the tree diagram, but you need to know the concept of combination. Okay, so for those who know combination, I'm going to teach you how to use combination and solve this problem without the need to draw the tree diagram. This is finding the answer for this, but you have to draw the tree diagram, which is very tedious. Okay, now let's look at a new method. Now, for example, this first drawn, this is the second, this third, this is the fourth drawn. Okay. Now the requirement is exactly two of them are white. That means I can have either white here, and then this other color, or the other choices will be white here, other color here, and white here. Okay, so if you look at this this way of analyzing, it's basically 4 spots, and how do you fill up 2 of the spot with a white? This is equivalent like a combination where you have 4 and you're going to select 2 of them. Cool. So this is basically 4 times 3 over 2. They will give you 6 way. Okay. They're all together 6 way. WW 0 others. This is 1 way. You got WO the second way. So all together there are 6 way. And these 6 way, they are not exact, they are different from each other. So there's 6 way arranging this. Now, so that is what you put in front. 4C2. Now, we're going to multiply with the probability of this. What is the probability of this? The W1, to get W1, the probability of W1 then time probability of white in the second draw, then other color in the third draw, which is this, time other color in the fourth draw. Okay, now 4C3, this is 1 way. Okay, then you could have the second way would be W1 time, sorry, this is a mistake. This should be the first. In the third draw, you draw the first other color. Then in the fourth draw, you draw the second other color. Okay. So if you look at this one, this is actually O1. This is the first draw, which you get other color. The first is even though it's the second draw, but this is the first time you get the first other color. So it's O1 time. This one is the second time you get a white. So this is W2. Then this is the second time you get other color. So this is O2. Okay? You can continue working out all the 6 way now. W1 times W2, these are probability, yeah? And time O1 time O2 is same as W1 time O1, then time O2, then time O2. Okay, so it's the same. If you have the 6 way, the probability of all this multiplication is the same. You get? So if you go all this until the sixth way, you have all these the same. Okay, it's only appear in the difference. The appearance of W1 and W2, O1 and O2, they are all slightly different. Okay, that create the 6 different way. Okay, now let's look at the probability of this. The probability of this W1 would be 5 over 12. W2 will be 4 over 11. O1 will be, there are 7 of them. Other colors, there are 7 of them, over 10 time the 6 of them over 9. Okay, now this is for the first one. The second one will be 5 over 12 time this 7 O1. There are 7 other color over. If this is the second draw, then there is only 11 left. So then the third one is W, so it's 4 over 10. Then the O2 will be 6 over 9. Okay. Now if you look at this, the denominator are the same. The numerator, if you multiply them, is also the same. So in other words, the 6th way, the probability are all the same. Okay. So in other words, the answer will be 4C2 will be 6th way time all this probability. Okay. This the 6th way, they are all the same. Only the position of the numerator and the denominator are at different position. So, but the product of them are the same. This product, the numerator product and the denominator product, they are the same. So, in other words, you just pick one of them that's good enough to represent. So, let's say pick this. It's 5 over 12 times 4 over 11 times 7 over 10 times 6 over 9. That's it. Now what about if I change this exactly 3 of them? How, using this methodology, how? Let's work out how do you do this. Okay? There are 6 of them exactly white. Now, in other words, means there are 4 drawn, 3 of them must be white. So become, using the same methodology, it will be 4C3. The 4 spot here, 3 of them must be white. So it's 4C3. If I work out this is actually 4C4 minus 3. This is actually 4C1, which give you 4 way. Okay, in other words, there are 4 bunches which will have exactly 3 white. Okay, 4 way means 4 branches, but using combination, I know how many branches are there that have 3 white. Okay, now, so what I'm going to do is I'm going to put a 4 in front here, time. I'm going to have 4 white and, 3 white, okay, 3 white and 1 other color. So what's the probability? Let's say the first white will be 12, 5, time the second white will be 11, times 4, times 10 over 3. All these are white. The probability of first white, second white, and third white, time the probability of first non-white, which is 7. Okay? This is just one of the arrangement where you have white, 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 and the fourth one is other color. But as I explained earlier here, they are all appearing at different stage, but the numerators, the product of the numerator and the product of the denominator, they are the same. Okay? So you just take one and that's good enough. So let's simplify this. That will give you the answer to have exactly 3 white. Okay? I hope you understand. So let's work out. So 4 times this become 3. 3 here cancel. Now 5 cancel this, come 2. This cancel this, come 2. So the probability is 14 over 99. Okay? Okay, so this is a probability for you to have exactly 3 of them white. Okay? Now, what about what's the probability if I have one of them, only one of them white? So basically, this is for exactly 3 white in 4 drawn, okay? In 4 draw. Now, what about exactly 1 white in 4 drawn? 4 draw. Now, then this is 4 C1, which gives you 4 way. Okay? Now, so 4 in front here. Let's find the probability of 3 white followed by 1 other color. So, so it's 1 white only. Okay, so the probability of 1 white is 5 over 12. The other 3 are all non-white. So, if we start out with 7 over 11 times 6 over 10 times 5 over 9. Okay, these are all other color. This one, white color. Okay, so the probability of getting 1 white from here, we will be able to get a probability without actually doing the tree diagram. Okay, as I showed you here, finding the probability exactly 3 white in 4 draw without working out the tree diagram. Okay, now let's look at this. So let's simplify this. Remember, this one is exactly 1 white in 4 draw. So 4C1 is 4 ways. That means there are 4 branches will end up exactly 1 white. Okay? Now, so if exactly 1 white, the probability of white is 5 over 12. This only one. The first drawn, we have a first white will be 5 over 12. Then the other ones is all other color. That means you start off with 7 over 12. Okay? Time 6 over 10. And then time 5 over 9. So to simplify this, 4, this 3, simplify this 2, simplify this, come 2. Okay? Now, then this will give you 70 above. This is 22. 2 times 11, 22 times 9 is 18. 18, so it's 198. So we come 198. Okay? The probability to have exactly 198 in 4 draw. So for those who know probability, this is a better way of finding the probability without resorting to drawing the tree diagram.